Okay, here we are. All right, team. Well, I'm sure that you missed me yesterday. Goodness knows I missed you. Yesterday I was feeling not terribly nice, so I stayed home for that reason. Today, well, if I'm being honest, it's still yesterday for me. But right now in my future and your present, I am going to be presenting at a conference in Niagara Falls. So that's where I am in your today, my tomorrow. And you guys are obviously still here in class. But I didn't want to miss out on a lesson. So I'm teaching this via video, which is vaguely embarrassing for me, but, you know, should be a good time. So here we are. Now you'll note, if you go to your unit tracking sheet, you'll see that we have done lesson 4.1. We've taken that, lines in the form y equals mx plus b. We've taken the standard form note. We did the graphing using intercepts. I've given you assignment 4.1. In fact, I did that on April 27th, if you want to put that now. And it is due Monday. And hopefully you finished it, yes, because you should have had lots of time to do so yesterday. But we are going to actually, for today, skip this. So I just don't want you to worry. We are going to come back to it. But today we're going to take lesson 4.5. The reason for that's simple. I think 4.4 is a little more complicated, and I just wanted to be there for it. So with no further ado, you should have a handout for 4.5, and we're going to get going. Now, it should come as no surprise that we know that we can define any line using the equation y equals mx plus b. And in this case, m equals, Maddie, I'm going to assume you said slope. If you didn't say slope, you should have. But if you didn't, that's okay. This is how we learn. And b is equal to, all right, Krish, I know you've had your hand up since I started drawing the green arrow. B is, that's right, the y-intercept. So we know that if we have a slope and a y-intercept, that's more than enough information to graph. But sometimes we don't have that much information. So what I want to remember is that the whole point of an equation is that we use it so that I can input some x value, and the equation will output for me. I'm actually going to draw it with an arrow going the other way. It'll output for me the y value. I tell it that x equals 3. It tells me that y equals 5. X is the information you give to the equation. Y is the information the equation gives to you. So we're going to look at a case today where I don't give you the slope and the y-intercept. I give you a slope and then some point on the line. And we're going to show that that's still enough information to make a line. It's enough information to make a line on a graph, which means it's enough information to get the equation to line. We just have to know how to do it. So first, we're going to prove this concept by doing this by graphing. So we're going to graph a line that has a slope of -3/2 and that passes through the point 1, 3. So obviously, we can't start by putting a slope on the graph because we have no idea where that slope should go. Even if we knew what the slope should be, in this case, -3/2, so we should know it should go down 3 and over 2. We have no idea where we should start to do that. It could look like this. It could look like that. It could look like this. And we just have no idea which of those lines would be correct. So I can't start with the slope, which means that the first thing we're going to start with is the point. All right, so the point is 1, 3. We know that 1, 3 falls on this graph. That is our point, and we're going to put it on the graph. So, of course, we're always very careful to make sure we know that 1 is the x value. So we go over by 1 and up by 3, and that's where that first point would live. Right there at 1, 3. So that's our first step. We put the point on the graph. Then we're going to use the slope, which we, of course, remember is rise over run, and we know what a negative slope means, and we know what a positive slope means. We're going to use the slope to give ourselves a second point, and maybe even a third point, just to check our work. And then we're going to connect those points to form a line. So pause the video, take a moment and do that. I'm going to assume that you just paused it and came back. So we know, of course, that the slope is rise over run. So in this case, it's going to rise by 3 and run by 2. And because it's negative, we know that it must slope down. So that means if I'm going down by 3, I'd go to the right by 2. If I was going up by 3, I'd go to the left. I'm going to make sure that the line has a basic downward slant to it, like that. So we would start here, and we would go down 1, 2, and then 3, and then over by 1 and 2. And from that, we would get our next point. And just to show, we could just as easily have counted up 1, 2, and 3, and over 2, and we'd have got our next point there. And I could also go down from this point, 1, 2, and 3, over 2. All right, and it just makes that little staircase. I could keep going and going and going. Rise 3 and run 2. But we get the point. We don't actually need all these points to make a line. 2 points is plenty to make a line. But next step, of course, is just to draw a line that goes straight through them. And by no means is that a perfect line, but compared to some of the terrible lines I've drawn, I'm actually going to say that's pretty good. I'm going to get rid of my little steps here. You don't have to get rid of yours. I just want this final copy that ends up online to look clean. So we put the point on, we use the rise and the run to get the next points, and we connect it to make a line. I want you to do the same for the next one. Pause the video, and I'll put this one on. I'll assume that we're back. And again, first we put the point on. So I'm going to go to -4, -6. And that's right down here. 4 to the left and 6 down. And then I'm going to use the slope. And again, the rise in this case is, let's say, Caitlin. That's right, 5. And the run is, oh, I don't know. Let's say Xander. Yeah, 2. Good. All right. Just, I can't actually hear you, so I'm just assuming you did it right. So we know that the rise is 5 and the run is 2. So from our point, we go up 1, 2, 3, 4, 5, and over 2. And I go to the right here because I know that this slope has to be positive. This has to be ascending. And I always like to put a second point on so I don't screw up 2, 3, 4, 5, 1, 2, and that would be my next point. And then I'm just going to connect them to make a straight line, just like last time. And always, if I've done my job right, it should work out perfectly. Now, things rarely do, of course, in real life work out perfectly. That is pretty darn good, I would say. So there we go. So all of this is, as I said, a proof of the concept. It shows us that if we have just one point and a slope, that's enough information to define a line. That's enough information to make a line, like we did here. What I want to show you on the next page is that we can use our algebra skills to do that same thing, but this time just using the equation. Just using the equation. And the thing we have to remember here is that y equals mx plus b is the general form of this equation. So, and we of course remember from the previous page that m is slope and b is y-intercept. So eventually, we're going to have a version of this where m is a number and b is a number. But the y and the x stay how they are. We want the y and the x to be the letter y and the letter x, because what that tells us is, hey, your output will be some number times x plus some number. Will be some number times the input plus some number. So in this case, we know the slope. The slope is given to us. It's 6 over 5. The slope is equal to m. So we can go ahead and put that number into this equation. We can say, well, wait a minute. Our output y is equal to the slope, which is 6 over 5, times x plus some letter b. But before this can be an equation, we still need to find b. And this, Krish, is just for you. That's right. We still need to find the y-intercept. I feel so lazy. But then again, I stayed home from work today, so maybe that's the appropriate way for me to feel. I don't know. So we still need to find the y-intercept. How do we do that? I haven't told you the y-intercept, but I have told you another point. We know that this line passes through the point 5, 3. In other words, we know that 5 and 3 are two numbers that satisfy this equation. This equation will be true when x is equal to 5 and y is equal to 3. So we're going to do that. We're going to let x equal 5 and y equal 3. All right, and you don't always have to write that, but I will show you here. If the x value is 5, that's going to get substituted in for x. And if the y value is 3, that's going to get substituted in for y. We're not substituting anything in for b because we don't know b. But we do know an x value that works with a y value. These numbers go in together because when x is equal to 5, y is equal to 3. That's a point that works on this line. So we can go ahead and do that. 3 is equal to 6 over 5 times 5 plus b. And now we are ready to actually solve this equation. Now it's solvable. So I'd like to give myself lots of room. I'm going to move up here because now we're actually going to solve for x. Or for b, rather. Pardon me, not for x. So we said, and I want to reuse these colors just so it's all clear. 6 over 5 was our slope. We put that in for m. 5 is the x value from that original point because we know that 5 is an x value that works for this line. It's possible for x to be equal to 5, and that happens when y is equal to 3. So that's where that information comes from. And now let's go over here where we have lots of room and solve it. 3 equals 6 over 5 times 5 plus b. Now my advice would be to simplify this mess. And I would just do it on my calculator. I would simplify this. You can, of course, do it by hand if you are feeling very algebraic. But I would just say, anytime you have here, because you're often going to have a fraction times whatever the x value is, it'll often be pretty nasty. Just do that. 6 divided by 5 times 5. And in this case, it's actually not a bad one. That just equals 6. So we can simplify that middle section there because 6 over 5 times 5 equals 6. So that whole thing can just become, 3 equals 6 plus b. Now if I want to get b by itself, what should I do to both sides? Let's say Lexi. That's right. Lexi said I should subtract 6 from this side because it's going to get rid of that 6. And then I'm going to say subtract 3 from this side. And then several people, not limited to, but certainly including Caitlin Ives and Caitlin with staff and Lexi are all going to be like, what are you doing? That's not right. And then I'm going to erase this. And I'm going to say, oh, right. What I do to one side, I have to do to the other side. So we subtract 6 from both sides of the equation. And that leaves me with what on this side? Well, 3 minus 6 is negative 3. And on this side, we have just b. We have successfully solved for b. Now, that isn't the end of the question, because the question wasn't, what is the b value of a line that passes through 5, 3 with a slope of 6, 5? It was, what is the equation? So we're going to answer the question, because we are question answerers all. We love to make sure that we always answer the question completely. So we would say, therefore, the equation this line is, just going to move that so it's not in the way, y equals, I have to remind myself, what was the m value again? Oh, it was 6 over 5. So y equals 6 over 5 x, and I'm going to put the b value in, and that, of course, is negative 3. I'm going to do a little bit of highlighting here, too, just to remind you where these numbers come from. Negative 3, well, we solved for that. That was the b value. And the slope, 6 over 5, well, that came from the original question. So y equals negative 6, or not negative, rather, y equals 6 over 5x minus 3. And that's the final answer to that question. I'm putting a box around it because I'm proud of myself. Okay, so I want you to try this next one. And it's the exact same steps, the exact same process. So you go ahead and try it. I'm going to join in. Okay, so I'm assuming that you guys have, chilled out and done this without me. Here we go. Well, we know that y equals mx plus b. And we know that we're going to have to put what information we do have into this equation. I'm going to do that all at once. I'm going to say that the slope, m, I can find up here. And it's negative 2 over 3. So I'm going to put that when I substitute this equation. But there's more information I can find out. I need a y value. And luckily, this point has been given to me, and it has a working y value. We know these always go in alphabetical order, so the first would be the x. So that's going to be my y value. And I need an x value. And I'm going to take that from here, the point as well. And the first value is always the x, because they just go in alphabetical order. So we're going to rewrite this equation, but with numbers. Oh my, got a text. It's from my sister, if you're wondering. So y equals, so far so good. Not y equals, we have a number for this. 4 equals. We are using the point negative 3 comma 4, so the y value that works there is 4. 4 equals negative 2 over 3 times, and we're going to put our x value in, which is negative 3, and then plus b. And again, we're going to work this out on our calculator, because I can't necessarily do this in my head. So I'm going to say negative 2 over 3 times negative 3 equals, and it tells me the answer to that is 2. So I can simplify this whole thing using that, and I know that it gets replaced with 2. So negative 2 over 3 times negative 3, that's a whole lot of algebra, but we can just replace that and say 4 equals 2 plus b. I'm going to say, okay, but what do I have to do to both sides now? And of course, Sam is going to be shouting at me through the computer screen. I can hear him all the way from Niagara Falls. He's saying subtract 2 from both sides. I'm saying, okay, Sam, you got it. We do that. And that tells us that 2 is equal to b. And then again, of course, that's not the answer to the question. That's just the work we had to do to be ready to give the answer. Now we have to actually make it an equation. And we would say, therefore, the equation of the line is y equals, and then the slope still just comes from the question, negative 2 over 3x. We want the y and the x there because that tells us we can use this equation to figure out the y value given any x value, but we want to put the b value in. We want to put the y-intercept, and that's plus 2. So y equals negative 2 over 3x plus 2. And then we would put a nice little box around that and a smiley face. Okay. Last thing I want you to try before I leave you to your own devices is this problem at the bottom. So pause it, and then I will try to explain it after. but I suspect you'll get. There's lots of ways to do this. See if you can do it using the method we did here. Though, of course, you're right that, that there's lots of different ways to do this. Okay, so we're back. Again, there's a lot of ways to answer this question, but I want to answer it in the style we did today. So I'm going to say that I must have given you, since this whole lesson is about a slope and a data point, I must have given you a slope, which is also known as a rate of change, right? And I must have given you a point. So what slope did I give you? What rate of change? Well, I told you that they charge $8 per gigabyte of data. That's a slope. That's a rate, right? Remember, rates are always something per something. So in this case, $8 per gigabyte, that's my rate of change. Now what about a point? Well, the point's easy. I used 5 gigabytes and it cost me 95 bucks. So that's my point. And that 5 gigabytes is my x, that's my independent variable. I control how much data I use. And that y, that's the dependent variable. I don't control how much money it costs me. It'd be nice if I did, but I don't. I don't get to say that. So, with that in mind, can we make an equation? Well, sure we can. We can always say y equals mx plus b, the general form of a line. And now we just have to put numbers in. Well, we already said we know the slope, we know the rate of change. That's $8 for every gigabyte. Do we know the x value? Sure, we know an x value. An x value that works is 5 gigabytes. That's a possibility. We can put that in. Do we know the y value that matches it? We do. When I used 5 gigabytes, my bill was 95 bucks. All right. So let's put these numbers into the equation. Oh, I like to do the highlighter thing, so I know where all these numbers came from. Okay, so let's do this. Well, the y value in this case is 95 bucks. And that's going to be $8 per gigabyte times, how many gigabytes did I use? Well, that didn't work well. I'm just going to have to go ahead and erase that. That's $8 per gigabyte times the 5 gigabytes I used, plus b, plus whatever that starting value is, whatever that initial value is. All right, and let me go ahead and recolor these. So that number is the slope. And that number is that. Now to do math, it's often not helpful to have all these symbols, so I would probably just say 95 equals 8 times 5 plus b. Now again, we've got to do this math in the middle. What is 8 times 5? Well, you probably don't need your calculator for this, but just for the sake of consistency, I'm going to do it. 8 times 5 is equal to 40. So we're going to say my $95 bill included $40 that was the result of my data usage, plus b, plus that initial rate. Now, how am I going to solve for b, that initial flat fee no matter what? Well, of course, Shayla is screaming, subtract 40 from both sides. And then she preemptively said 40 from both sides, not 95 from one of them. And that's very kind of her, because she's right. I probably would have made that mistake. So I subtract 40 here. I subtract 40 there. And that leaves me with, that's right, 55 equals b. And in this case, that actually is the answer. I mean, I still haven't answered the question. I'm going to use my words because I'm like that. But that is the answer. Because that b value, that's the y-intercept. That is the starting flat fee. So the flat monthly fee is, what was it, 55? Yeah. It's $55 before any data usage. There we go. So I gave you some homework right on this sheet, and I hope you'll go ahead and do that. And I hope you have a wonderful weekend. Be kind to one another. Don't do anything that, I don't know, let's say Sammy Sparks wouldn't do. And I will see you all on Monday. Ciao.